In this video, we will cover testing differences between proportions. Testing differences between proportions is similar to finding confidence intervals for proportions, in that we will use the z-distribution instead of the t-distribution. In order to calculate the z-ratio, we need the difference in the proportions over the standard error for the difference in proportions. So here's the formula for that. And then above is the formula for the standard error of the differences between sample proportions. And you will notice in this formula we have something called P star. P star is the proportion for the entire sample when we only know the proportions and sample sizes for the two groups. And we can work backwards to determine an overall proportion using this formula. To illustrate this, we're going to use a question from your textbook, which reads, a researcher is interested in gender differences in attitudes towards flying. Polling a sample of 100 men and 80 women, he finds that 36% of the men and 40% of the women are fearful of flying. Test the significance of the difference in the sample proportions. So that's what we're going to do right now. So let's enter in the data that we know so far. We have 100 men, that's the size of the first group, and 36 of the men are fearful of flying. So we're going to turn 36% into a proportion by just dividing it by 100 to make it 0.36. And then we have 80 women in the survey, and 40% of those people, women, are fearful of flying. So we're going to put 0.40 for that proportion for the women group. So our first step right now is to calculate P star, or our total sample proportion. And the formula for P star is right here above. And so I'm going to put an equal sign. And I'm going to do the numerator first, which is n of 1 times P1 plus n2 times P2. So that's the numerator right there. Over, and I'm going to put this in parentheses as well, n1 plus n2. And this gives us a P star of 0.38. P star as a proportion will always be between 0 and 1, and it should fall between the proportions for the two groups. And as you can see, 0.38 is in the middle of 0.36 and 0.40. It won't always be right in the middle, but in this case it certainly is. And now that we have our P star, or our shared proportion for the two groups, we can calculate our standard error, which is this formula right here. Since it's one of those formulas that has multi-steps, I'm going to go ahead and calculate it in parts. So the first thing I'm going to calculate is P star times 1 minus P star. So I'll just do that over here. Our P star was 0.38, and I'm going to multiply 1 minus P star. Okay, that's the first part of this equation. And the second part is going to be the term that has to do with the sample size. So I'm going to do equals, and for my numerator first, I have n1 plus n2, and the parenthesis there, over n1, and I'm going to put that in parentheses as well. Oops, that didn't work. Hold on for just one moment. n1 times n2. Whoops. There we go. And so that's the second part of this equation. The last thing I'm going to do is find the square root of the first part of the numbers plus the second part. So here we go. Equals SQRT. And I'm going to pick the P star, not the P star, P star minus, or times 1 minus P star. I got that. And then I'm going to multiply that by the sample size term. And I end up with a standard error of 0.07. I'm just going to move that right over here. So I have it all together. So our standard error of the difference between the sample proportions is 0.07. And so now we have everything we need to figure out the z-score. I'm going to put an equal sign here. And it looks like for my numerator, I'm taking P1 minus P2, close the parenthesis. I'm going to have it over our standard error. And that gives us a z-score of negative 0.55. The critical z-score, just as with confidence intervals at the 0.05 level, is 1.96. Since negative 0.55 is smaller than 1.96, we retain the null hypothesis. The null hypothesis, if you will recall, is that there is no difference in fear of flying between the men and women, and our analysis confirms that the null hypothesis is indeed retained. Does that make sense? If not, I'll see you on the discussion board.